This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Welcome back for the 10th week. This is the anniversary in a sense, since we're in the 10th week and we have learned a lot so far. But we are not finished yet. We have still more to learn. There are like 5 more weeks till the end. And we are going to learn pretty important and interesting stuff until that time. I hope you have downloaded your code. If you have questions about things that you did not understand up until now, please ask. So are there questions about things that you didn't understand? If not, we can continue. Download today's code for the 10th week. And we will see what are they about. Okay. Now, up until now, when we were writing programs, we assumed that our users, the users that are going to use our programs, are educated, in the sense that when we expect from them to enter a string, a data of type string, they enter string. So when we ask from them, give your name, they will give their name, not their age. And when we asked from them to enter their age, they did not give their name. Okay, so when we expected an integer, the user gave an integer as an input, and when we expected the string, the user gave a string as an input. But as a programmers, you might assume that not all of the users are like that. Okay, you should expect something like wrong input, wrong data input, or wrong type input, or whatever. That's why we are going to deal with this stuff today. We can continue with the input check file. So let's start a new project from scratch, from beginning. Okay, it's going to be an empty project. Usual empty project. Copy the inputCheck.cpp file and paste it to the solution folder. Now, just add this existing item, inputCheck.cpp, and let's see what this piece of code is doing. So let's run the program first, and let's see what it is doing, and afterwards we are going to explain how this is done. Okay, enter number of real numbers to be added up. So I'm going to give I want to give 5 numbers as input, real numbers, but I'm saying 5 numbers, and this 5 is an integer. And afterwards I'm going to give real numbers of type double, and I'm going to add them up. So I want to give 5 numbers, and now the compiler is expecting a real number. So I'm giving 25.45. Okay, it's accepted. But what if I say 25.39? Should this guy be accepted? No, since the compiler, the computer, doesn't recognize the comma. When we represent double numbers, float numbers, actually real numbers, we represent them with a floating point, with a dot, not with comma. Okay, so that's why this comma 39 is not accepted. Only 25 is accepted, so we have 25.0. Now the program is prompting me, asking me to give another input, another real number. And let's say that I'm giving Artrim as a real number. Is this a real number? No. That's why Artrim is not a real number. This is the message we get. So let me give another real number, 56.0. Another 15 real number. So I've given up until now 1, 2, 3. This is the 4th one, 0.79. And this is the 5th 9, 34.5. And we got the sum. I forgot to put the system pause here, or CIN ignore CIN get. Let me write pause here. So basically the program added up the numbers. Let's run it again. So the compiler here is accepting enter number of real numbers. Number of real numbers is what kind of type? So if I say 5 real numbers, 5 is what? Come on. What kind of type is 5? It's integer, okay? But what if I say, okay, blah, blah, blah. Blah, blah, blah is not an integer, okay? But if I give 3, then this is going to be accepted. This is an integer. And I'm expecting 3 real numbers. So if I give 45.78, this will be accepted. If I give 34 and something like this, interestingly, this 34 is going to be accepted. This is how the compiler works. How CIN works with real numbers. Okay, you might say, this is not in all, it looks like a string. But 34, 3 and 4 are digits, so it's kind of an integer number. And automatically, the compiler converts this integer number to real number, to double number. And it's going to be 34.0. Okay, so it's going to be accepted, but only 34 is going to be accepted, not this part, this substring after the 34. So this AS or this thing that does not make sense is not going to be accepted, but 34x is accepted as 34.0. And if I give 56.4 or 56 only, this is going to be accepted as 56.0. So the sum is 135.78. If we add up 45.78 with 34.0 with 56.0, we will get 135.78. So this 78 is here. Now let's see how it's working, or better, let's do some theoretical stuff behind the code. Let me explain something that you didn't know about CIN. So we have seen classes up until now. You can assume that CIN is a kind of a class, kind of. So class CIN. We have some public data here. And up until now, we have used only one public member function of CIN, and that's the operator arrow. We read data with this, so we have used something like, let's say, integer A and CIN arrow A. Okay, we have been using this stuff. But what happens in the background is not that simple, okay? That's why we're going to see some stuff today. We have something which is called clear. This is a function. We'll see what it's doing. And we have something, this is a variable, flag. It's a variable. I'm not sure whether it's public or not. I think it is, but I'm not sure. And I'm not sure of the name, but I'm going to tell you what it's doing. So this is flag. And we have another variable. Let's name it buffer. Maybe the name might be different, but let's name it buffer. Buffer meaning we temporarily put some data here. So if we have something like this, integer A, CIN A, we're trying to read A to get data for A. And if I give, let's say if I give rtrim as an input for the buffer, while we are expecting to read A, what happens in the background? What do you think? So if I prompt the user, give an integer number, and I give rtrim as an integer number, that rtrim is going to be stored here in a buffer. Okay? But hey, this A is of type integer, and it expects only integer data. It's not going to accept any string or character or whatever. Only integer data. So what's happening is the following. We use the operator, but since we cannot assign rtrim to A, this is what happens. If I give 5 as an integer, as an input, this 5 is going to be assigned to A, so flag will be 0, meaning we don't have any mistake. But if we have a mistake, this flag is going to be set to 1, and operator CIN, or operator arrow, is a kind of a function that returns true or false. So this returns true or false. Actually, it returns 1 or 0 when it's false. So when this guy cannot put the data to A, it returns false. Okay? And this flag is set to 1, meaning we had a mistake. And the data that we just enter remains in the buffer. Okay? But if I give 5 as an input, so this is what happens in the mistake scenario. In the case when we give a wrong input, wrong type. But if I give 5, let's say as an input, and I'm trying to read this one, so I give 5, and I'm trying to put 5 to A, the flag is going to be 0. And this operator error returns true, meaning that the reading operation was successful. Okay. So again, let's say so when I give this 5 to A, this buffer is flushed. So when I put 5, so we have A here, and I give 5 to A, this buffer is erased, it's empty, we can put another data inside. This technique that I just explained will be used to do the program that we just did, meaning that when we ask for input for a certain type of input, we are going to be sure that we will get that we are going to give the right input. Otherwise, we will not accept it. So let's see how this is done. Let's go with this function here. This function here has no parameters, and it returns an integer always. Its name is inputInt, meaning that I'm taking an integer as an input. So for sure it returns an integer. We declare an integer variable called number, and here we are giving inputs for the number up until we are sure that it's integer. And if it's not integer, we are going to repeat it again and again. But if it's integer, this CIN is going to be true. Okay. Negation of true is going to be false. So while false, so we are going out of the loop and we return the number. Let's see how it's working. I'm going to play the role of the compiler for this function only. And you will, if you understand it, you will not have the problem with the program. You understood the program basically. So we have a variable called num. Let's say this is my screen here. And I'm giving inputs here. I'm expecting an integer. So let's say I'm in the beginning. I've declared the num. So this is the inputInt function. And I want to be sure that in the end I'm going to return an integer as a number. Nothing else. No string, no character, no double, only integer. And I'm asking CIN num, and I'm giving, let's say I'm writing here rtrim, and I'm pressing enter. And when I'm pressing enter, what the CIN is doing is the following. So initially the buffer is empty. I'm writing this rtrim to the buffer. It's always like this. And then I'm trying to pass this rtrim to the number. But hey, I have a problem here. Because num is an integer, but the buffer has a string input. That's why this CIN here is going to be unsuccessful. So when this is going to be unsuccessful, it's going to return false or 0. But I have a negation here, and that negation is going to make this CIN, this while loop, to be true. That's why I enter inside. And what I do inside the while loop is the following. I have another string. I define another string s. I say CIN clear. Because if an input cannot be given to a certain variable, I cannot use CIN anymore because of this flag here. So when I wanted to give a string input to a integer variable, the flag was set to 1, meaning that I cannot use CIN anymore. But when I say CIN clear, this flag is going to be raised and it's going to become 0. Okay. Then I'm putting this CIN to the string S, the buffer, and whenever I put it here, the buffer is flushed. And only when it's flushed, when it's empty, I can expect and I can take another input. So this is flushed. The buffer is empty. I can take another CIN, another input. The flag is set to 0, and I'm writing here that S, that rtrim, is not a string. Okay, and new line, go to a new line, and I'm writing, please enter an integer. Please enter an integer. Again, I'm going at the beginning of the while loop. Now let's say that I'm giving an input, as an input something like this. Blah, 5, blah. Okay, so this is my input. And this blah, blah is going to be put to the buffer. Blah, blah. Blah, blah, 5, blah, blah. And I'm trying to put this blah, blah to the number. But this number is not an integer. That's why the operator arrow, the input stream operator, this is called input stream operator, is going to return false. And this negation is going to make it true. So basically I'm saying, while I give a false input, repeat this stuff again. And what's the stuff? I declare a new variable S. I'm clearing this flag. So when the CIN was unsuccessful, this flag was set to 1. Okay. Then I'm clearing this flag because I cannot use CIN if this flag is set. So it was set to 1 when the output was unsuccessful. I'm clearing it, I'm flushing the buffer, and I'm writing it here. Blah 5, blah. And I'm writing the same message. That blah blah is not an integer, please enter another integer. Okay? Now let's say I'm giving as an integer 34b. So I'll go in the beginning. At the buffer, I have 34b. You might think that this is a string, and yeah, it looks like a string, but this is how the CIN, the input stream operator works. It's going to take this 34 and put this 34 to the number, okay, and CIN is going to return true. So this CIN now will be true, and I'm saying not true. Negation makes it false. I'm going outside of the while loop and I'm returning number, okay. So I'm going to return this 34. So this is how the program works. Of course, if I give a proper integer like 57 without any character, it's also going to be accepted. If you understood this, you understood a lot of things. So this is the input integer function. Very similar to the input integer function is the input double function. The only difference is that here we are expecting to return a double, as you can see it here. And the number is not an integer, it's a double. And we are repeating, we are doing the same thing all over again, nothing else. So with input double, we are sure that as an output, as a result, we are going to get a double number. We are sure, and we make sure it with, we assert that with this while loop by saying, up until the number you have read is not a double of double type, you cannot put it to the number, repeat this again and again and again. Any questions? Did you understood this? Because it's important to understand it. If you understood it, if you don't have questions, we can continue. If you have questions, please ask me. Because we are going to see it a lot of times today. So it's very important and critical to understand this stuff.
How did you create the buffer?
How do I what?
How did you create the buffer?
Buffer is inside the class CIN. So when you declare the guys that have written the class CIN, they've declared a variable called buffer. Okay, I'm not sure about the name, whether it's buffer or no. Maybe it might be another name. But there is something a buffer, meaning memory that takes any input. Okay, and initially it's stored here before storing it to other allocated memory.
What is the flag?
Well, the flag is something of a Boolean type, 0, 1, true or false. And when let's say that I'm expecting an integer variable, and the CIN is not successful. When the CIN is not successful, because the buffer has a string input, like AB, let's say, then the operator is going to return false, and this flag is going to be set to 1, meaning there was a mistake. This buffer could not be sent to the integer type, okay? And if this flag is set, I cannot use CIN anymore. In order to use it, I have to clear it. I have to make it 0, meaning I don't have any error, and I have to flush the buffer. Okay, I have to put this buffer to something that makes sense. And string is okay for everything, for integer, for double.
Clear, like what? Where does it clear the flag?
Yeah, it clears the flag.
Oh.
Okay, so clear is related to the flag. It clears the flag, so we can use CIN. Basically, if I don't write this saying clear, I cannot put the buffer, the data inside the buffer, I cannot transfer it to the string S. If I don't use that, okay, it will be a mistake. Any questions? So it's very simple. I mean, you just have to pay attention and ask, nothing more. So this was about input double function. It's very similar. Basically, it's doing the same type. The only difference is that here we make sure that the returned value is of double type. The number is double. So let's go to the main function. Here we declare number n, which is integer, a double, two doubles, which is the double number that we are taking, and the sum. Initially the sum is 0. So let me run the program, enter the number of real numbers to be added up. So I'm going to give an input, and this will be n. So input integer is going to return for sure an integer, and I'm going to put this integer to n. So if I give, so I'm expecting integer. If I give rtrim as an input, rtrim is not integer, please enter integer. If I say 34a, then 34 is accepted, and now I'm expecting 34 double numbers. So n is the number of double numbers that I'm going to enter. So I start from 0 to 34 to 33 basically, meaning I take 34 numbers, and I prompt this, enter a real number, and I should expect a double input and put it to num. You remember that num is of double type. So I'm giving 25.4, 27.6. If I give something that makes no sense, it's not going to be taken because this is not a real number. But if I give 45 and something that makes no sense, this is going to be accepted, only the 45 stuff. But if I give something like this, and I have 6, 7, 8, 9, so we have digits here, in the end, it's still not going to be accepted. So only the first digit are going to be accepted. So this guy, blah, 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 with 6, 7, 8, 9, 7, is not an integer. And so on. I don't have time to do that. Again, let me give a smaller number of input. So I have 3 numbers, so 45.7 again. 34 is going to be accepted as 34.0. 45.90. The sum is this much. So with this for loop, I take a double input. So input double function assures us that I'm going to get it assures us that it's going to return a double. That double is assigned to num, and I add this num to the overall sum, and in the end I print the sum of the numbers. This is it. Okay? Any questions about this example? If not, let's go and see another example. So remove this guy. We don't need it anymore. We're going to see the average of integers CPP. Average of integers CPP. Just copy it, place it to the solution folder, add it, And let's see what is this function doing. First, let's run it. Oh, it needs string utilities because we are going to convert strings to integers. That's why just copy paste all of those libraries, namely the string utilities, the random generator, and the prompt. We will see the prompt library later on today. Copy paste them here. We're going to need all of them, and just add the string utilities. Okay. Let's run the program and see what it's doing. Enter an integer and I'm giving 23. Another integer and I'm giving 34. Another integer and I'm giving something that's not integer. And this integer is not accepted. Okay? And I give another integer which is 1. And when I want to finish, I press Ctrl Z. And what's the average of those numbers? And I press enter. Oh, I forgot the system pause stuff. I think that it should be put automatically for all of the examples, but never mind. We can write it again. So, enter an integer. Let's say I'm giving 2. Another integer, I'm giving 6. Another integer, I'm giving something that makes no sense, and this is not going to be accepted because it's not an integer. I don't get a message that it's not accepted, but it's not accepted. Now let's give 4 as an integer. So up until I press Ctrl Z, so this is Ctrl Z, and I'm using Ctrl Z to get out of the loop. So what's the average of 2, 6, and 4? The average is 4. Okay. When I press enter, I get this message, average is 4, meaning that this string data was not accepted. Okay? This is what we are going to do in this function. Of course, if I press Ctrl Z initially, what's the average now?
0.
Why 0? Did I give an input? No integers entered. I mean, you cannot say the average is 0 by default because if you don't have numbers. Why do you say it's 0? I say it's 100. But okay, I understand you. I mean, I was just joking. Okay, so you see what the function is doing. So there is a while loop, and in order to while loop that reads integer data, if it's integer, it's been accepted. It's not. It's just disregarded. It's not taken into account. And finally, I find the sum, and I divide it with the number I've entered. I find the integers, the average of the entered integers. Let's see how it's done. First, we have here a prototype function, which is called isInteger. Basically, it takes a string as an input, as a parameter, and it checks whether the string that I've taken is of type integer. And I'm repeating again that everything can be encapsulated inside a string. String accepts any type of data. Integer is also a string. Okay, it can be easily converted into string. Double is also a string. Characters are string, and of course, string is a string. Booleans are also string. If I write false and I put parentheses, I put quotation marks, it will be taken as a string. Okay, false or true, which are Boolean numbers. So I have here a function, prototype function. It's called isInteger. Takes a string as an input, and it returns true or false by taking into account whether this input, whether this string can be converted to integer or not. And this is the function. I'm going to explain it now. So, just focus here before explaining this function. If I say 34b, do you think that this is an integer or not? Yes or no? I mean, logically, is 34b an integer? Or 34w? Or 34r trim? Is this an integer? No, you would say no. But we saw that CIN works in the following manner. If I give 34r trim, this 34 will be taken and will be regarded as integer, and the r trim part, the substring, I mean the part up to 34, will be just discarded, not be taken into account. Okay? I don't know about you, but I don't agree with this logic maybe. My logic says that in order a number to be an integer, all of its characters should be digits, meaning something from 0 till 9, in between, okay? From the range 0 to 9. All of those characters one by one. And this is what the function is doing. I'm taking a string, and I'm checking whether all the characters are 0 or 9. So the logic behind this function is the following. I'm going to erase this stuff. How can I figure out whether a certain input is an integer or not? Meaning all of its digits are integers or not. Let's say that I have something like this. 3, 7, 5, 6. This is our input, and it's of type string. I have a counter that initially is 0. And I go check each character one by one from the beginning till the end, and I see whether all of those characters, digits, are between 0 and 9. So I check this one. Is 3 between 0 and 9? Yes. I increment the count and put the count to be 1. I go to 7. Is 7 between 1 and 0? Oh, 0 and 9? Yes. I increment the count and I make it 2. Is 5 between 0 and 9? Yes. I increment the count and make it 3. Is 6 between 0 and 9? Yes. I increment the count and make it 4. I'm finished now. So in this string here, I have 4 digits. What's the length of the string? So input length is how much? Is what? 4. So you see, the count and the length of the string are the same. Okay? That means that all of the characters inside the string were digits. So this is going to return true, meaning that, yeah, we can easily convert this to a string. However, if I give something like this, 3, 2, A, 5, and I start counting the number of digits. So I start from 0. So, yeah, 3 is between 0 and 9, so count is 1. I go to 2. Yeah, 2 is between 0 and 9, count is now 2. A, is A between 0 and 9? No, it's not. That's why I'm not increasing the count. I go to 5, yeah. 5 is 3. And I'm finished. What's the length of the input? It's 4. And I'm comparing the length of the string and the number of digits. I see that the number of digits is smaller than the length of the string. That means that at least one character in the string was not a digit. So I'll say that this guy, this input is not a string. And I'll return false. That's why I have this return value initially put to false. If the count is equal to the input length, I return true. And whatever this is true or not, I return the return value, which is of Boolean type. Okay? Can you figure out the function? Very briefly, this is what I'm doing. Again, with code. I mean, we saw the algorithm, the logic, how it works. This is the count. Initially, it's 0. We count here the number of digits. Return value is false initially, because I assume that it's not an integer. But I'll check it later on. The length is the length of the string, of the input string. Okay, now I start from 0 up until the length, meaning I check each character one by one. And if I'm using the substring function, you remember the substring? The first index, the first parameter here, takes tells us at which index we should start, and this one tells us that we should take only one character. Basically, if I start from 0, and I have 1 here, I start from 0 and I take only one character, the 0th character. When this I is incremented by 1, I take the first character, only one, the second character, and so on. And I check. If this substring, actually that certain character, is smaller than 9, and if that character is greater than 0, what does that mean? Smaller than 9, greater than 0. It means that it's a digit. Smaller or equal to 9, I'm sorry, and greater or equal to 0, that means that it's a digit and I'm increasing the count. So I'm repeating this loop again and again. And finally, when I go out of the loop, that means that I've reached the end of the string. I compare whether the count is equal to the input length. If they are equal, the return value is going to be true. Otherwise, if they are not equal, the return value will remain false, and I'm going to return it as it is, or true or false. Okay? Now there's an interesting stuff here. You have this operator, smaller or equal. You remember the date class that we saw last week? We could compare dates, smaller, equal, greater, equal, and so on. Now you might be, how can I say? Now you might wonder, how can we compare strings? Okay? Greater, which one is greater? Which one is smaller? Well, can I compare 0 and A? Can I compare comma and semicolon, comma and full stop and 5? Well, you can do it, but for this stuff, in order to do this, you have to include, okay, IOStream should be enough. And there is something which is called the ASCII table. Have you heard about the ASCII table before? Yes or no? Do you know what it is about? Well, during the Second World War, if I'm not mistaken, the American military had to communicate their units between each other. But of course, when you communicate, at that time, you could use signals like 0 or 1, okay? You cannot send a string, or even telegrams work this way, okay? Remember the Morse code, dash and dots, beep, 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 beep. That means you have 0 or 1. If you know what's 0, 1 in binary numbers, you can convert this binary to decimal numbers. So what they did, they came out with a table which was called ASCII table. It stands for American Standard blah blah blah. I'm not sure about the abbreviation. You can check it, you can Google it. And this is it, okay? So you start from 0 in decimal, and you go up until 125. I'm sorry, not 256, 125, meaning you have 127. Yeah, 127, meaning that you have 128 characters, because you started from 0. And let's say the 60th character is the sign smaller. The 61st character is the sign greater, okay? Now where can you find the digits here? Can you help me? Yeah, the digits. So, 0 is the 48th. The number of 0 is 48. The number of 1 is, no, 0 is 48, 1 is 49, 3 is 50, and so on. So basically, can you tell me which is greater? Character 0 or character A? Which one is greater? A is greater because the ASCII number assigned to A is 65. And the ASCII number assigned to 0 is 48, okay? So when you compare characters, you should have in mind this table, okay? So everything that comes, let's say, after 0 is greater than 0 in terms of the ASCII table, and every character that comes before 0 is smaller than 0. And what we are doing with our program, we checked whether our characters are in this range, okay? So digits are in this range. If it's smaller, if it's greater or equal to 0, and smaller or equal to 9, meaning that it's a digit, okay? So let's go back to our code. Basically, this part of our code, those operators, smaller, equal, greater, or equal, are using the ASCII table. So the character that we have taken with this substring, and we have taken only one character, that's why I'm telling character, not a string, it's a character. If the character is smaller than 9, smaller or equal to 9, or greater than or equal to 0, that means that it's a digit, and I'm increasing the count of the character. Now, this is the isInteger function, which makes sure whether all of the digits are integer or not. Let's go to the main function. Let's go to the main function and see what it's doing. So I want to find the average of integers. So initially the number of integers is 0, the average is 0, the sum is 0. I'm defining a string which is called words, and I'm printing this prompt, enter an integer. And I'm reading this word. And of course everything that is going to be read is an integer. So I define another integer value, and I'm using the function isInteger, and I am sending the word as its parameter. Basically this is the input for the isInteger function. If it returns true, that means that this word we have just entered is consisted only of digits. Okay? That's why we are going to convert, if this word is consisted only of digits, we are going to convert this word into integer using that toy function. You remember that toy function from string utilities. Okay, it converts strings to integer. It returns the integer. It's assigned to the int value. This int value is summed up to the overall sum and increase the number of integers by 1. We again print this prompt, enter integer. We go in the loop, CIN word, and so on. So you might wonder, okay, when we are going to get out from this loop, because CIN word is always going to be true. Okay? Since all the inputs we enter, we give, are going to be accepted from the CIN, because everything is a string. Okay, integers are string, doubles are string. That's why I'm repeating it again and again. Integers are also strings, can be easily converted to string. Are accepted as strings. Double numbers also, characters also. Even empty string is a string. In order to come out from the loop, you can just press Ctrl Z. And this is not only to come out from the loop. If you're a bad programmer, if you write a program that makes no sense, and you are going to loop forever, it never stops, you just press Ctrl Z and the program will halt immediately. Okay? So if you encounter this problem, your program doesn't stop, press Ctrl and Z and your program will stop. So when you press Ctrl and Z, when you give it as an input, then we are going outside of the while. And if the number of integers is not 0, if I've entered at least one integer, then I'm finding the average, and average is a double, and I'm printing the average. Otherwise, if the number of integers is 0, then I'm printing that no integers are entered, and I'm finishing. So let me run it again. So we are here. We have defined all of those variables. We are writing this prompt, enter an integer, and I'm giving 5. Okay, it's taken. So isInteger 5 is taken. It's converted, the word 5 is converted to integer. It's added up to the sum which initially was 0. Okay, and I'm now prompting again, enter an integer. And I go here. Now I'm entering something like this, rtrim. This makes no sense. This is not integer. When I press enter, isInteger word is going to return false, since none of its digits here is an integer. I'm going to write this prompt again, enter an integer. Again, when I'm asking another integer, if I write 4, 5, RTY, our user-defined isInteger function is not going to accept this, because not all of the characters are digits. Now if I give 10, this is going to be accepted. And if I press Ctrl Z, what's the average? How many integers do we have here? We have 2 integers, 5 and 10. All others are not integers, and they're not accepted. So when we come out from the while loop with Ctrl Z, the average is 7.5. 10 plus 5 is 15, divided by 2, since we have 2 integers, is 7.5. And also, If I just press Control Z immediately, no integers entered, because if the number of integers is not equal to 0, if it's 0, this will be false. So we go to this else clause, we print no integers entered, and the function is finished. So this is the problem. Did you understand it or not? How many of you? Raise your hand. Okay, the guys that are late, I don't expect them to understand it. Otherwise, you're a genius. You understood it. You came late.
I understand the...
Okay, you are smart. Okay.
But I don't understand why when we enter Control Z,
it's from the compiler. Yeah, it's a rule.
And it's not about the code.
It's not about the code. It's always like that. So if your program stucks, and you will have problems like this, you are waiting 2 minutes, 3 minutes, 5 minutes, 10 minutes, it never stops. It's just looping. Usually you have an infinite loop, we call it. We're writing while true, and never comes out. You can just use Control Z, and it will get out from the loop, and will halt. We'll finish. Okay, we will be back after 5 minutes. You can have your break.